Hello viewers, welcome back. I'm Dr. Maya. I have already explained you how to create the mesh for the 2D slabs, walls, stairs. For each 2D member, you can create a local mesh. After generating local mesh, you can go for the calculation. Once the calculation is done, now you have to design the slab panel or wall panel. So in my case, I'm going to design the slab panel. For this, you will simply go to the design and from here, go to required reinforcement of slab walls options. Remember, you're not going for design directly, but you're going for the options because you have to do code parameters, calculations, and table. So first of all, you should go to code parameters. Here are the code parameters. Don't forget that these are RC floors. You have to select the RC floors. So you can go to floors directly. And from here, you can select all the floors panel, floors, select all. And these are all the floors. You can see from 30 to 340. So now you will activate this panel 30 to 34, 302 to 302, etc. All the floors are selected. Now you will apply it. You will apply it. So here it is obvious that these all panels have been selected and sorry, we have to design the parameters. And again, I will show you the whole procedure design, required reinforcement. And here we are going to the code parameters. RC floor, and it will be applicable on floors, all floors. So just click it and then select all and then activate this and then apply. Now it has been applied, you can see. And now I'm going to close it. Again, going to the design, going for the calculations. But first of all, we have to define the different properties. So mostly it come ULS, LS analytical method. I'm going to calculate it. After calculating the calculations, I am going to close it and again going to the design. Required reinforcement. I am going for the table shell and reinforcement. Here you can see the different things for all the values, global extremes, info, calculation parameter, ULS, SLS, calculation method, analytical, averaging method, local. So after doing this, let's go to the table, reinforcement maps. Let's go for the reinforcement area. And SLS is cracking and scale. These are the areas. Here you can see how it's going. So mine is going to my first picture and zoom on. You can see this red is 0.17. It is the negative one. So Y negative, apply. You can see X positive, apply. You can see Y positive, apply. You can see for spacing, you can come here and see apply spacing. These are the spacing in inches. Number of bars. Let's go to the number of bars. apply. You can see where 3, 2, 1, and here everything is visible. So even let's uh, check for the SLC cracking, X negative cracking, apply Y minus cracking. You can see the values from here, apply, and so on. This there are different zero cracking and different cracking. You can see from here, and this is the scale. So after that, I'm going to go again to the table. Now you can see that here it is written that which uh, what are the required reinforcement areas in square per foot. So here everything is given. Somewhere negative is required, somewhere it is positive. So depending upon the load you have applied, you will have this. For this case, mostly 0.17 is being used, the area, and from here you can get very good idea how to design the slab. Thank you very much for watching. Uh, please wait for the next um, video where I will make everything more clear to you. But from here you can understand that what will be the reinforcement negative AX, negative AY, positive AX, positive AY. So thank you very much for watching, and don't forget to like and subscribe. Thank